then we'll turn the pumps and you will stop. So what we're going to do here is, after we start the system, make sure that everything runs fine. We're going to first of all fix the pressure here at 30 psi. We will start with that value of the pressure. This is the discharge side. This is the pump. Okay? The pump takes the water down from the reservoir and takes it up to that reservoir. Okay, so this is the discharge side. So we have the discharge side, and this is the suction side. Okay? This, again, is connected to the suction side and will record values. So these are negative pressures and are measured in millimeters of mercury that need to be okay, these are PSI. We'll talk about the conversion later. Now, we'll talk on so when the system is running, we make sure that the pressure here is at 30. As soon as we fix the pressure at 30, we measure 1, the deflection of this manometer. And from the deflection of this manometer, when you do the calculations, you guys will measure Q, the flow rate. Okay? 2, the RPM of the motor and the RPM of the pump using the stroboscope. Okay, the pump should be at around 2400, the motor should be at around 1700, something like that. 3, the vacuum recorded at this gauge and the pressure recorded on the discharge side. And 4, we will attach a spring here and we will measure the force that is transmitted by the motor to this system, which will give us the torque, and then we will do the calculations for the power out from here. Okay, once you're done with this set, you open a little bit the valve to let the pressure go down at 28. It's going to be a little difficult to stay right at the You repeat the measurement. 1, 2, 3, 4, 5, 6. Down at 26. 1, 2, 3, 4, 5, 6, and so on. Until you should get at around 16 when the valve is completely open. Okay, so you should have about 6 to 7 measurements before the valve is completely open. Once the valve is completely open, you take all the measurements again. After that, what we will do is we will set our stroboscope so that the RPM of the pump will go 200 RPM below the last value. So if it were at 2,400, it goes down to 2,200. Okay? And how we'll do that? We set the stroboscope at 2,200, say, and we use this lever to make sure that the motor slows down until we reach the 2200 speed that we want. Once you get the 2200, you repeat the measurements. 1, 2, 3, 4, 5, and 6. Then you reduce the RPM of the pump of another 200 and go to 2000. Set the stroboscope at 2000, use this to regulate the motor until your pump slows down at 2000. Once it's at 2000, repeat the measurements again, and you are done. So with the first 6 measurements, you will build what is called the characteristic curve of the pump. So basically you are acting as the engineer from the manufacturing plant that is testing the pump. The last 3 measurements that you recorded, the one at open valve, the first 2200 and the second 2000, will be used to build the parabola that is your system curve. Okay? Once you are done with all the measurements here, we shut off the system and you have to measure the length of the pipes from the reservoir to the pump on the suction side. From the pump to that reservoir there, we will do kind of an approximate measurement. read about the, the elbows, and you need to look for the loss coefficient in the fluid mechanics book and determine the head losses for the whole system. Okay? We will talk about the type of measurements that you need to do at the end once you're done with this.